We all live our lives online, but have you ever just stopped and thought about the physical journey your data takes? It's not magic, that's for sure. It's this massive, incredible chain of actual hardware. So today, we're going to follow that journey, starting right from the blinking box on your desk and going all the way to the heart of the network, the data center. Let's get into it. So let's start with that one box you probably walk past every single day. The one in the corner with all the little blinking lights. It seems so simple, doesn't it? But that little box is your own personal gateway to the entire internet. So what is really going on inside that thing? All right, first stop, your home's network hub. I kind of like to call it the all-in-one wonder box, and that's because it's doing way, way more work than you probably realize. And here it is, our first big surprise. That thing you call a router? Well, it's not actually one device. It's more like a team of 4 different devices, all cleverly squished together to fit into that one little box. It's kind of a quiet masterpiece of engineering, really. Okay, so who are the 4 players on this team? Well, first you've got the modem. Think of it as the translator. Its job is to take the signal from your internet provider and turn it into data your devices can actually understand. Second is the router. This one's the diplomat, connecting your private home network to the huge public internet. Third, we have the switch. This is like the mail sorter for your house. It makes sure that email goes to your laptop and not, your smart TV. And finally, the wireless access point, or WAP for short. This is the magic part that lets you connect without plugging in any cables. Okay, so we've got the home network down. Now let's scale things up. We're going to go from the living room to a big office building. And what's really wild is that the principles behind it all, they're exactly the same. They're just about to get a whole lot bigger. In a big office network, what we call a local area network, or LAN, that clever little all-in-one box gets totally broken apart. And why is that? Well, because you need each component to be a specialist. So instead of one box doing 4 jobs pretty well, you have 4 separate, super high-performance devices, and each one is purpose-built to do its single job perfectly for hundreds of people. So what does this actually look like in the real world? Well, instead of that one box on a desk, you have these big, powerful, specialized components. And they're not all in one place. They're often spread throughout the building and tucked away in these large cabinets. This helps keep that massive web of cables organized and, of course, keeps all that expensive hardware safe and sound. But here's the thing, all this separate equipment is pretty useless unless it's all connected. And that brings us to the network's lifelines, the actual physical cables that stitch this whole thing together. Now, we basically have 2 main players here. First up is copper cable. This is the workhorse of most networks. It just sends information as simple pulses of electricity down some copper wires. Pretty straightforward. Then you've got fiber optic cable, which is, well, it's a little more futuristic. It sends data as pulses of light that are zipping through these unbelievably thin strands of glass. So electricity versus light. And this leads us to a classic engineering problem, a trade-off. See, on one hand, you've got fiber. It is ridiculously fast. We're talking literally the speed of light, and it can cover huge distances without any problem. The catch? Yeah, it's expensive. Then on the other hand, there's copper. It's much, much cheaper, but it's slower and the signal starts to fade pretty quickly. So every single network is like a giant puzzle. The designers have to pick the right cable for the right job, always balancing that equation of speed, distance, and cost. Now, all of these cables, all these different devices, they have to lead somewhere, right? And that somewhere is the brain of the entire operation, the server room. Every large network has a heart, and that's the server room. This is central command, just packed with servers and switches. And hey, that note about it being air-conditioned, that is absolutely critical. All this hardware running 24/7 generates a ton of heat. Seriously, without some industrial-strength cooling, the entire network would just melt down. This is a really important rule in networking. No device ever talks directly to another one. I don't care if it's your desktop computer or some super powerful server. Every single message has to pass through a central switch or hub first. It's the traffic control center that makes absolutely sure every little piece of data gets exactly where it's supposed to go. Okay, so our network is built, but now it's time to tackle a classic engineering challenge. How do you beat a fundamental physical limit of your own equipment? Remember our workhorse cable, that cheap and common copper cable? Well, it turns out it has one major flaw, a critical weakness that becomes a huge, huge problem in any big building. And here it is, the limit, 100 meters. That's it. It's about the length of a football field. Go any further than that and the electrical signal carrying your data just fades away into static. Poof, it's gone.
So this presents a very real problem, right? How do you give a network connection to a desk in an office that's, say, 150 meters away from the main server room? You can't just use a longer copper cable. We know that won't work. So, what's the solution?
And the solution is actually brilliantly simple. You build a hub room. It's like a mini server room, but with one key difference. There are no servers in it. It's just a little outpost with some switches, and you place it strategically in a far-off corner of the building. Now all the computers in that area can connect to it using their short, cheap copper cables.
And this is where it all comes together beautifully. To connect that distant hub room all the way back to the main brain, you use a single, powerful fiber optic cable. Since it uses light, it can easily cross distances way greater than 100 meters. So you get the best of both worlds. You use the cheap copper for all the short runs and the powerful fiber for that one long haul. Problem solved.
So there you have it. From that simple little box in your home to this complex web of cables and switches in a massive building, it's a whole invisible world of clever, engineered solutions that we rely on every single second. So next time you plug in a network cable or even just log on to Wi-Fi, maybe you'll remember the incredible physical journey your data is about to take. Now that you know how it's all built, what do you think we're going to build with it next?